Let T denote the time in minutes for a customer service representative to respond to 10 inquiries. T is uniformly distributed on the interval with endpoints 8 minutes and 12 minutes. Let R denote the average rate in customers per minute at which the representative responds to inquiries. Let FR be the density function for R, determine FR. So the big T is uniform on 8 to 12. So we know that the uniform distribution has a PDF 1 over B minus A. So 1 over 12 minus 8 is 1 over 4 from 8 to 12. And now the big T is the time in minutes for 10 inquiries, right? Big T is the time in minutes for 10 inquiries. And the R is the customers per minute, which means inquiries per minute. So that's the inquiries in 1 minute. So if in T minutes we have 10 inquiries, then in 1 minute we will have 10 over T inquiries. So that's why the R equals 10 over T. And now as far as the significance of these kind of ranges is concerned, they just match up with what we are given for the original variable. So T goes from 8 to 12. So you can see that when T is 8, the R will be 10 over 8. And when T is 12, the R will be 10 over 12. But since 10 over 12 is smaller, so that's why for the R we write 10 over 12 to 10 over 8. So we need little f of r, and as always, we have to start with big F of r. So big F of r equals probability big R is less than equal to little r, and the big R is 10 over t. So 10 over t is less than equal to little r. So we have to solve this for t. So if you take t on the right side and bring r down here, so we get t, big T is bigger than equal to 10 over r. And that means that so now we're talking about this variable big T, and for big T it's this function g. And so remember again that we call it g of t instead of f of t because the f was for something else in the problem. So we want t greater than equal to 10 over r. So it means it goes from 10 over r to infinity, and the big T is associated with the function g. So integrate that from 10 over r to infinity. But the function g is just defined from 8 to 12. So instead of going 10 over r to infinity, we just go 10 over r to 12 because 12 is the highest. And the definition of g of t was 1 over 4, the uniform. And so the integral is t over 4 from these limits. And then I pull the 1/4 out and put in the limits. So multiply 1 over 4 through, I get 3 minus 5 over 2r. Now, it's a very common mistake in these problems to have this as the answer, and they'll always have this kind of an answer in the choices. So actually 3 minus 5 over 2r is one of the choices. But remember that this 3 minus 5 over 2r was the big F. And so the little f will be the derivative of the big F, and the derivative of this is 5 over 2r squared. So it's actually choice E.